The sun is dying, the 9 stages that will end Earth. We usually meet this story at the red giant. That is late. The sun's end starts while the sun still looks familiar. The sun is about 4.6 billion years old. It is still a main sequence star fusing hydrogen in its core. That current state has lasted for billions of years. But core hydrogen fusion describes only one phase in the sun's long physical evolution. As the sun changes, Earth does not wait for one final dramatic event. Earth starts losing habitability while the sun is still in its long main sequence phase. The red giant comes later. This countdown follows the physical order. It starts with core fusion. It ends with a white dwarf. The question is simple. When does Earth stop working as a world for life? Stage 9 is the sun right now. It is about 4.6 billion years old. It is a main sequence star. Its core is fusing hydrogen. That is the physical state behind the sunlight reaching Earth today. The sun is changing while it does this. From Earth, the observable result is ordinary daylight from a familiar star. The surprising fact is that the core fusing sun does not hold one brightness forever. Its luminosity slowly rises. That happened before the red giant. For Earth's biosphere, it matters first. Here is the question that drives the rest of the timeline. What does a slowly brighter sun do to Earth before it ever looks dramatic? Stage 8 is the rising luminosity line. As a sun-like star ages on the main sequence, its luminosity gradually rises. The sun still fuses hydrogen in its core. On a timeline, the sun's disk has not yet changed into a red giant, but the energy trend has already changed direction. The line goes up. Earth receives more energy from the same star. That is the first concrete break between the sun we know and the sun Earth will eventually face. It is a boring-looking line on a chart. That is the trouble. There is no one-day signal in the sky. The modeled consequence builds over spans far longer than a human life. Earth developed under one range of solar conditions, while a future Earth receives conditions that move away from the range that supported its biosphere. The star has not become a giant. The planet has already started getting a different deal. So which gives way first? Earth's orbit or Earth's habitability? Stage 7 is where Earth loses the range it was built around. The cause is still the sun's slow increase in luminosity. Nothing needs to explode for the outcome to matter. Earth receives more energy over time, and the modeled future is a planet that cannot keep the conditions life needs. The exact timing depends on the model. The order does not. The sun brightens during its main sequence phase. Earth becomes hostile to life before the sun becomes a red giant. From Earth, the observable implication is not a new planet or a new star. It is the loss of the stable surface conditions that made a biosphere possible. That is the first reversal. The giant sun is the image people remember. The earlier loss is a living world becoming unlivable, while the sun still looks broadly familiar. So does Earth's biosphere last until the famous red phase? Stage 6 exposes the two-clock problem. Earth becomes hostile to life long before the sun reaches its red giant stage. One clock tracks a living Earth. The other tracks the physical fate of the planet and the sun. They do not reach zero together. The sun has not yet exhausted core hydrogen or expanded into the familiar red giant, and it remains a main sequence star whose luminosity has gradually risen. But the biosphere's future is already decided by that earlier change. The exact timing of habitability loss is model dependent. The order stays fixed in this countdown. First comes gradual brightening. Then Earth loses habitability. Only later does the sun become the huge visible object in the usual illustration. The red giant is a late chapter in the two-clock story. For life, the decisive event is the loss of conditions that allow life to continue. That is the stranger fact here. We remember the red image because it is easy to draw. The biosphere fails earlier while the sun still looks much more familiar. Once the biosphere is no longer viable, a different question takes over. What happens to the sun after its long hydrogen fusing phase finally ends? Stage 5 keeps those two clocks apart. The sun stays in its main sequence life for a very long time. Core hydrogen fusion still defines the sun during that interval. Earth's biosphere does not need to survive until that phase ends. One question is whether Earth remains habitable. Another is whether the later red giant physically engulfs it. Habitability is lost first. Engulfment, if it happens for Earth, belongs to the later red giant stage. That is a weird order, but the timeline keeps insisting on it. Earth can remain in orbit and still stop being a living world. The gradual brightening has already decided the life question. The next change decides the fate of the inner planets. What happens when the sun exhausts core hydrogen? Stage 4 is core hydrogen exhaustion. In roughly 5 billion years, the sun is expected to exhaust core hydrogen. That ends its main sequence phase. The current core process cannot continue in the same form forever. When the core hydrogen phase is exhausted, the sun changes its structure and expands, beginning the red giant evolution that will reshape the inner solar system. This is the start of red giant evolution. No blast switches the sun over. Core hydrogen exhaustion leads into expansion. For the inner solar system, system, the modeled implication is a much larger sun. For Earth, the order still matters more than the spectacle. Earth has already become hostile to life before this expansion begins. The red giant is therefore not the first threat to the biosphere. It is the later stellar transformation after that earlier loss. Roughly 5 billion years puts this far beyond human life and history. The model still gives the sequence a clear order. Core hydrogen runs out, the sun expands. Then, the inner planets face the phase that changes their physical survival. Which worlds are expected to be inside the expanded sun? Stage 3 is the red giant. After core hydrogen exhaustion, the sun expands into a red giant. This is the well-known image because the physical change is easy to understand. The sun is no longer the compact main sequence star of the earlier stages. Its expanded outer reach changes the inner solar system. Mercury and Venus will be engulfed in this future red giant expansion, which means the inner solar system cannot keep the familiar arrangement it has during the sun's main sequence life. Their separate orbits do not survive as they were. Earth's fate is different because the correct statement is not certain. Engulfment. Earth may be engulfed. That word matters. May is not a rescue for the biosphere. By this stage, Earth has already become hostile to life long before the red giant arrives. So the remaining question is about the planet's body rather than its biosphere. The remaining uncertainty concerns Earth's physical fate as a planet. Its living surface has already become hostile to life. Schroeder and Smith examined this distant future in 2008. Their paper is Distant Future of the Sun and Earth Revisited. That paper keeps the red giant where it belongs. In scientific modeling, the sun's expansion is a real part of its expected evolution. Mercury and Venus are expected to be engulfed. Earth may be engulfed. Then even the red giant does not remain. What does the sun become after it loses its swollen outer form? Stage 2 is the planetary nebula. After red giant evolution, the sun will shed its outer layers into a planetary nebula. The red giant is not the permanent final shape of the sun. Its outer material is shed outward. A distant observer would see the material around the central remnant as a planetary nebula. The name is old and misleading because this phase is not about making planets. It is the sun's former outer layers moving away from the core that remains. The physical story has now moved through several distinct forms, each following from the previous stellar state rather than appearing as one sudden ending. A hydrogen-fusing main sequence star became gradually more luminous. Its increasing luminosity made Earth hostile to life. After core hydrogen exhaustion, the sun expanded into a red giant. Then, it shed the layers that made it a giant. Earth's exact physical fate remains tied to the earlier red giant uncertainty. Nothing in the planetary nebula stage restores a habitable world. That part of the timeline was settled far earlier. The next question is smaller in scale but final in direction. What remains at the center after the outer layers have gone? Stage 1 is the white dwarf. After shedding its outer layers, the sun leaves a hot white dwarf core. This is the remnant after planetary nebula formation. It is not a main sequence star. It is not a red giant. It is the compact hot core left after the sun's outer layers are gone. A distant observer would see a much smaller stellar remnant at the center of the shed material. The white dwarf then cools over vastly longer times, carrying the sun's future beyond the dramatic phases that dominate almost every simple illustration of its death. There is no return to the sun's earlier hydrogen-fusing main sequence state. There is no return to the giant phase either. The future ends with the remnant star cooling as the solar system becomes harder to recognize. The image gets smaller after the red giant, but the timeline is still moving. The sun begins as a main sequence star. It gradually brightens. It expands. It sheds outer layers. It leaves a white dwarf. Earth's life-supporting chapter ends much earlier in that chain. That is the fact the countdown is built around. For us, the red giant is not the beginning of Earth's end. It is the late familiar image from the second clock. The first clock stops when Earth's biosphere can no longer survive the gradually brightening main sequence sun. Only after that does the sun exhaust core hydrogen and expand. Only after that do Mercury and Venus get engulfed, with Earth possibly following. Then the sun sheds its outer layers and leaves a white dwarf. The real twist is the order. Life ends first. The red giant only makes the already late chapter easy to see.